Gasoline. Liquid power to run millions of automobiles everywhere. Yet, how many know what happens to the gas after it is poured into the gas tanks, or realize the care that motor car engineers have taken to give each drop an equal chance to do its duty? Gasoline is powerful, but each drop can give a 100% account of himself only when he finds the most efficiently designed gasoline system to help him along his journey. For a successful life, every drop of gasoline depends entirely upon what happens to him after he gets in the swim. Ah, a nice one. Let's go after that drop of gasoline. So this is what the inside of the gas tank looks like. All right, we'll have to dive too. Here goes. No, this isn't the water main. It's the gas line from the tank to the engine. It's a good thing it's cool in this gas line. If it ever got warm, the gasoline would form vapor, and the pressure would hold the gas back in the tank. But we won't get stuck because this pipe is on the right side of the car, while the hot exhaust is far over on the other side. This is the gasoline pump that's been pulling the gasoline along all this time. Well, here we are in the little glass bowl below the gasoline pump. It's made out of glass, so the owner can easily see any sediment collecting on the bottom and have it removed whenever necessary. But we can't stop long here. Guess the only place we can get out is through that screen up there. And is that going to be tough? The holes are certainly small. 14,000 of these tiny holes to the square inch keep dirt from reaching the carburetor. Even water can't get through this screen. Whoa, he seems to be stuck. Must be a bit of dirt clinging to him. But as soon as it comes off, he'll get through all right. There, he made it. The pump is a trusty friend of the gasoline. Always supplies just the right amount. Whenever the car is going uphill or makes a sudden burst of speed, the pump automatically works harder. But we've got to keep moving on to the carburetor. We just came through the needle valve that lets the gasoline into the carburetor. That is the float on top of the gasoline. It controls the needle valve, keeping just the right amount of gas here in the bowl of the carburetor. Hey, there goes our drop again. He's going down through the metering jet at the bottom, but he's still in the carburetor. How's that for wind? It roars through the carburetor, sometimes at a speed as high as 800 miles an hour to vaporize the gasoline. That funnel above and the other one below are called Venturi tubes. They control the speed and direction of this hurricane of air. 3 tubes in this carburetor keep raw gasoline from getting into the engine. An important reason why the 6 cylinders of this engine run on a very small amount of gasoline. But look, there's our drop over there again. Say, he's getting bigger. He's being mixed with air. He'll grow up to be about 17 times his original size, so he can do his best when he gets into the cylinder. Right down to the manifold that distributes the gasoline to the cylinders. Ouch! We're standing on the hot spot. All the drops mixed with enough air are floating right on past. The others stop here to be vaporized. This manifold heater cuts down waste and lets each drop of gasoline do its best. Here we go down the manifold. Gasoline is whirled through the manifold to keep the mixture uniform, speeded up in one place and slowed down in another, so the same amount of gas gets into each one of the cylinders. These are the valves that control the gas going into the cylinders. These big intake valves certainly make it easy for gas to get into the cylinder. No crowding, no pushing, no waste. Important for gasoline economy. There's the spark plug up there, just in the right place to burn all this gasoline. And here comes that great big piston. There's the exhaust valve opening up. And here comes the piston again. Lucky they made the exhaust valve large, too, so we can get out in a hurry. There goes the ghost of our drop of gasoline. Thanks to the engineers, he's given a perfect account of himself. He has led a more fortunate life than lots of other drops. Of course, every drop must go from the tank to the exhaust. But they don't all have the economy adventures met by every drop of gas which goes down this gasoline trail.
you for this unsolicited testimonial. And now, by special permission of the Commander-in-Chief, me, here is Mars' first space explorer, Colonel Cosmic.
I can't tell you how happy I am to see your smiling faces once more. First, let me say that this trip was made possible only by our dauntless chief, Og the Magnificent, introducer of Og Power, which runs most of our industry, and inventor of Og Speed, which doubles the original Og Power. A short time ago, the master was having trouble with the state limousine. He had, of course, developed the explosive charge. But it was inclined to get a little out of hand, just slightly. And, of course, there was always the problem of friction. Parts rubbing together, heating up, and causing all sorts of trouble. But our leader was undaunted. He immediately ordered our first expedition into space to bring back the secret of how other planets got their state limousines to run smoothly. The target was picked with painstaking scientific accuracy. Destination Earth. You all know with what eagerness I volunteered for the mission, and with what confidence I took off. I took careful bearings and set out for my goal. It seemed no time till I was approaching a country of Earth called, the United States of America. I set her down like a feather. What's all the racket? Naturally, I protected government property by making the saucer invisible. They're after the chickens, Ma! And though the natives showed great interest in me, I decided to make myself invisible, too. Seeing moving lights in the distance, I headed for them. What phenomenal luck! I had landed close to what seemed to be an endless procession of state limousines. They moved quickly, and yet with fantastic smoothness. I just had to get a closer look at one of those Earthmobiles. Just as I thought. Not only smooth and efficient, but powerful as well. I watched them for hours. Great Ganymede, they were superb. I just couldn't help comparing them with ours, if you call that a comparison. Surely these vehicles must be the property of the highest officials. I was wrong. It seems that almost everybody in this country has one of those, they call them automobiles. They use them for transportation, for business, for pleasure. They use them for all sorts of things. I found that these vehicles gather at places called service stations, where they are fed, lubricated, that's how they beat friction, and given the finest care. The source of their nourishment was something called petroleum. A power source like that must be a highly prized state secret. I had to find out about it. Perhaps the secret lay within this government archives building. It was heavily guarded, but casting discretion to the winds, I walked boldly inside. Their code was remarkably easy to break. They merely substituted the word oil for petroleum. And I soon got hold of a veritable mine of classified information. I began to assimilate the material. I soon found out that though petroleum products are easily found anywhere, petroleum itself is a very elusive substance. Experts have to search for it constantly in all the most likely and unlikely places with all kinds of scientific devices. When they figure they found a good spot, they drill a hole in the ground called an oil well, for almost all oil lies far beneath the surface of the earth. These wells go down thousands of feet and cost a lot of money to drill. But that's no guarantee that they're going to find oil. Matter of fact, in exploratory drilling, only 1 well in 9 finds any oil at all. Only 1 in 44 recovers enough oil to pay for itself. And only 1 in almost 1,000 makes a major discovery. Pretty big odds. Yet America's proved reserves, the oil supplies still underground, have kept increasing steadily. I couldn't imagine how this ever-increasing supply of oil was achieved until I found out that there's not just 1, but thousands of oil companies, all competing with each other to discover and develop new sources of oil. For believe it or not, in the USA, anyone who is willing to risk it can drill for oil. But oil discovery is only part of the story. Once they get oil out of the ground, it has to be moved through pipelines, on ships, or in tank cars to fantastic processing plants called refineries. Crude oil goes in, and great Jupiter, the things that come out. Gasoline, for example, the most efficient mobile power source on Earth. That was the stuff that powered all those cars and trucks. And asphalt, which makes smooth, durable roads. It seems that oil not only runs cars, it even gives them something to run on. Another oil product is the diesel fuel, which runs giant trains across the nation. In winter, fuel oil made from petroleum brings warmth and comfort to millions of homes. And still other fuels help defend America's shores and skies. From refineries also come the lubricating oils and greases that keep the wheels turning in America. But that still isn't all. Crude oil, like everything else, is made up of billions of tiny molecules. And using the magic of research, oil companies compete with each other in taking the petroleum molecule apart and rearranging it into, well, you name it, fabrics, toothbrushes, tires, insecticides, cosmetics, weed killers, a whole galaxy of things to make a better life on Earth. And you know, it isn't just oil companies that try to outdo each other, competing for the customer's dollar. The same story is true of almost every successful business enterprise in America. The result? A higher standard of living in the USA than in any other country on the whole planet. At last, the secret was mine. And now, to get proof of my discovery, smuggled past the border guards. In spite of my infinite precautions, one of them became suspicious and gave the alarm.
Come back for the eggs, did you? Yeah.
And so, with the fond farewells of the natives ringing in my ears, I took off once again for Mars. My landing was a little bumpy, but I saved my precious cargo. Yes, I brought the secrets back with me, and here they are. The big secret is, of course, oil, which has brought a better life to all the people in the USA. But the key to making oil work for everybody is competition. Fellow Martians, I thank you.
Very interesting, Colonel. Oil, huh? Sounds splendid. But that, what was it? Competition. Not our kind of thing at all. Why, competition is downright unmarked.
Oil? We'll have oil for everybody. That's what we need. Oh, boy, oil!
Look at them. You know what this means, Cosmic?
You bet I do, Og. It means that you're through. So why don't you get lost? Yes, the real secret is not only a great source of energy, but also the freedom to make it work for everybody. And if you have both of these things, any goal is possible. It's Destination Unlimited.
Extra, something extra. Posies for the girlfriend? Yes, sir. And an extra Bloss Elmer to wear in his buttonhole. Everyone likes that little something extra. A dozen rolls, and the baker tosses in an extra one to make it a baker's dozen. The butcher throws in an extra bone for the bow wow. Every locality has a different name for it. Way down east in New England, they call it something to boot. In the deep south, they call it lanyard. At your neighborhood service station, they call it Esso. The new Esso gives you premium performance, unexcelled at regular price. And the new Esso Extra is unexcelled at any price. Extra quick starts, extra power, extra anti-knock. You can take your choice. These two great gasolines are both extra value for the money.
For service that is tops and gas that's extra fine, there's a smile for every mile at the Esso sign. E-S-S-O makes your car go. Happy motoring.
Two great gasolines, Standard Red Crown and Standard White Crown. The fuels that power this modern age. On the highways, on the farm, and their kindred aviation fuels in the air. Here is the inside story of these modern gasolines.
Hello, folks. I'm a carbon atom, and since I'm an essential part of each of the hydrocarbons in crude oil, I'm here to give you the inside dope on gasoline. I'm the smallest possible particle of carbon. Why, I'm so small, 1,000 billion atoms like me could dance on the head of a pin. Scientists know I act as though I had 4 arms. And these fellows, who are the hydrogen members of this combination, have only 1 arm. We're going to form a molecule. Watch. I grab hold of hydrogens like this, then another carbon. In doing this, we make a kind of chain. See? When we're together, the combination is a hydrocarbon molecule, one of the many, many different hydrocarbons. For instance, we have formed a typical gasoline molecule. Now I want you to meet some of my relatives who form in the same way but have different patterns.
I'm another hydrocarbon, a gas molecule. My size makes me a typical kerosene molecule. I'm one of the fuel oil molecules.
A light lubricating oil molecule. That's me.
rotating oil molecule.
All of these carbons and hydrogens make me a residual materials molecule.
So you see, there are lots of different molecules, different sizes, different shapes, all found in crude oil. Still the best raw material for the great motor fuels of today. From it, science builds gasoline, selecting the groups of molecules wanted and changing their sizes and shapes as required. To do this job calls for great storage tanks to maintain a constant supply of crude oil. Batteries of pumps. A maze of valves and pipes. Mighty facilities. And an army of experienced, specially trained workers. The first step is to separate the crude oil into the parts that you saw a moment ago. This is done by distillation. You know that when you boil water, the vapors can be condensed. The same principle is used in distilling crude oil. Giant units with bubble towers condense vapors just as the cold tumbler did. Here in a single tower, much simplified, crude oil is separated into the different fractions needed for gasoline, kerosene, fuel oil, and other petroleum products. Here we see the crude oil being heated. Most of it is vaporized. At the bottom of the bubble tower, unvaporized large molecules of heavy lube oil and residual materials are drawn off. At the second level, the light lube oil is condensed out of the vapor and withdrawn. At the third level, the largest of the lighter remaining molecules condensed to form the fuel oil cut. At the fourth level, kerosene is condensed and drawn off. At the fifth level, the gasoline molecules become liquid, leaving the very light gas molecules to go out the top of the bubble tower. In the average crude oil, only a limited amount of gasoline is present. So let's see what we might get from this simple distillation. A barrel of crude oil produces 20% residual fuel oil and asphalt, 7% lube oil and wax, 39% gas oil and fuel oil, 15% kerosene, 1% gas, and gasoline only 18%. Not nearly enough for today's millions of cars. But scientists of the Standard Oil Company, Indiana, invented the cracking process, enabling refiners to make more than twice as much gasoline from each barrel of crude. Today, were it not for the demands for fuel oil and diesel fuel, almost the whole barrel could be converted into gasoline. By making more gasoline, cracking has conserved our natural resources and at the same time made gasolines of higher anti-knock quality for greater performance and economy. Here's a typical gas oil molecule to be cracked. You are already familiar with the way it's constructed. To crack it, heat is applied under precisely controlled conditions. More heat than is needed for distillation. And now, folks, you are watching science change a molecule into more useful ones. On the left are two gasoline molecules. On the right are gas and carbon, all obtained from cracking one gas oil molecule. Thus, science creates gasoline where none existed before, high anti-knock gasoline. Here are some of the great units that do the cracking. And here's one that cracks tens of thousands of barrels of gas oil each day. Standard's continuing leadership was also strengthened by other processes. One is called polymerization. It simply takes molecules that are too small for gasoline, such as these gas molecules, unites them by the polymerization process to form a larger molecule, a gasoline molecule of exceptionally high Antonov value. Thus, science again fashions for us more and better products. By a somewhat different process, this alkylation unit joins together two different molecules to make another high-octane gasoline component. And this unit, a hydroformer, changes the shape of molecules and takes out some of their hydrogen to make still more high Antonov material. Finally, a process where cracking is affected by a catalyst, a reaction promoter that itself remains unchanged. The most modern method uses catalysts in a fine powder that will flow like a fluid. Here's what happens inside a fluid catalytic cracker. Gas oil is heated. It is joined by the hot, finely powdered catalyst shown here as little white grains. The hot oil and the still hotter catalyst then move together through pipes up into a chamber called the reactor and are tumbled about. Here the heavy oil molecules are cracked by catalytic action to produce gasoline molecules shown in red. These move out at the top. As the catalyst becomes covered with coke, it becomes less active and is drawn off at the bottom. Air blows it through a pipe to the regenerator, where the coke is burned off. This reheats the catalyst, which again joins the flow of incoming oil. Here's the entire operation showing the complete cycle. Notice that the same catalyst is used over and over again in this, the most modern method of gasoline manufacture. It takes a complicated unit to do the job. Every 2 minutes, a whole carload of catalyst passes through the lines. 16 stories high, each of the company's big cat crackers can produce enough gasoline in one day to last the average motorist 1,000 years. Contrast the modern unit you have just seen with this historic Burton cracking still at Whiting, Indiana, the first successful commercial cracking unit. Though the amount of oil in today's catalytic cracking units is actually less than in the old Burton units, the catalyst cracks the gas oil more than 7,000 times faster, and so permits much greater throughput. It is one more demonstration of leadership through science. To build top gasoline performance today, there are two major requirements: proper volatility and proper Antonov quality. Let's take the first one, volatility, the tendency to change from liquid to vapor. The driver may not know a cat cracker from a firecracker, but he knows when his engine starts. And he wants it to warm up without coughing and sputtering. But starting and warm-up are not the whole story. In all seasons, the motorist wants quick acceleration. He wants economy, too. Mileage. And that calls for a scientific balance of gasoline components. You know how easy it is to ignite gas, which is made up of small molecules. Here's a mixture of liquid hydrocarbons so light and volatile that the heat of a hand will make it boil. It's inflammable and so volatile it ignites plenty fast. Now here are some of the heavier, less volatile hydrocarbons. The lighted taper does not ignite them, yet when vaporized and burned in an engine, they pack a lot of power and give mileage. To make a gasoline blend that will have a proper combination of volatility characteristics, first we put in the very light hydrocarbons for quick starting. The next heavier ones have rapid warm-up. Then some that give instant acceleration. And the final portion for full power and good mileage. The blended gasoline has the desired range of performance with economy because it contains just the right groups of hydrocarbon molecules. One, for instance, starting, but so active that in the summer he should be used only in moderation. One for rapid warm-up. One for smooth acceleration. And one for full power and good mileage. Molecules that work together, a harmonious team. In the engine laboratory, by means of a glass intake manifold, you can actually see one of the volatility differences between fuels. Slowing down the action, here's what too low volatility causes: a wet manifold and imperfect distribution. These liquid droplets decrease engine performance, waste mileage, and dilute the crankcase oil. Switching to a fuel with proper volatility, vaporization is complete and there's no waste. To assure trouble-free performance at all times, fuels are tested out on the road as well as in the laboratory, in all types of engines and under all of the different seasonal and climatic conditions of use. Under city driving, and trip conditions in hot weather and cold. Seasonal variations and the climates of different regions must be taken into account. That is why the Standard Oil Company, Indiana, adjusts volatility to suit the season and the region in which its gasolines will be used. A distillation test measures the volatility of motor gasoline. The results here plotted form a typical distillation curve for a gasoline of proper volatility. Now for the next major requirement, the prevention of fuel knock. The motorist wants smooth, controlled application of power. Using a special demonstrator, I shall show the difference between poor performance and good performance. Now, with the hard face of this mallet, I strike the piston. The piston, you see, receives a punishing rap, showing how power is wasted when gasoline knocks. This time, I shall use the cushion face of the mallet to show what happens when gasoline does not knock. Smooth, useful power propels the piston, sends the crank spinning. The performance difference you've seen is a mighty important one that you ought to understand better. So let's look inside the engine by means of animation and see what happens when the fuel burns. These gasoline molecules have not been improved on or controlled by science. They are untamed and unruly. What you will see next actually takes place in about 1/500th of a second. First, the spark ignites the compressed fuel charge. Now, watch for the knock. In this greatly slowed down action, you could see that with this gasoline, combustion was uneven and uncontrolled, and at the end there was a jarring, violent explosion, a knock that pounded and shook the engine. Now we shall repeat the action. Watch again for the knock. Now, with gasoline made up of molecules that have been science-fashioned so that they have the required anti-knock quality, molecules that stay under control and work as a team, let's see what happens. Note in this case that the combustion is more uniform and there is no knock. The big difference, as you could see, is that with gasoline of the required anti-knock quality, there is no knock. Combustion is smooth and even and completely under control. Now we shall repeat the action. Watch how the combustion proceeds as it should, smoothly and without the interference caused by knocking.
In the modern high-compression engine, modern gasoline gives the greater performance required today. The car accelerates more rapidly, climbs hills faster, travels more miles per gallon. In addition to fashioning the molecules to prevent fuel knock, refineries usually add minute quantities of tetraethyl lead to help accomplish the same purpose. This model shows how just the right amount of fluid containing tetraethyl lead and dye is added to the gasoline.
In the knock testing laboratories, test engines are used to make sure that the proper anti-knock quality has been built into Standard Oil's gasolines. The high anti-knock reference fuel is called isooctane, hence the expression octane number. This test engine is equipped with a dial indicator that shows just how badly the engine is knocking. With a fuel of low octane number, here's how it sounds. Switching to a high octane number fuel, the knocking diminishes and finally fades out completely. This illustrates the smooth, even performance you get from Standard Red Crown and Standard White Crown. The engineer has had his say, but modern processes and skillful know-how are not enough. There must also be safeguards. You can depend on it that Standard Oil Company, Indiana, constantly checks and inspects its fuels by every needed control test. For example, the vapor pressure test that controls vapor lock tendencies. A test to make sure there is no harmful gum. Another to make sure that today's fine gasolines will not deteriorate in storage. A test that guards against corrosive impurities. Testing, testing, testing. Another of the 1,500 and more daily control tests. In addition, these great laboratories are entirely devoted to extensive research. Carried on by hundreds of capable scientists, working on more and still better products for the future. Cooperative work with the automobile industry guarantees that the right gasoline will always be available for any car that's developed. Put all of this together and you have what it takes to deliver today's and tomorrow's great motor fuels. Huge units like this superfractionator and the other multi-million-dollar units that go to make up the great modern refineries of the Standard Oil Company, Indiana. With the tradition of pioneers behind us and better facilities ahead of us, future progress leading to still finer products is assured. So there's the story, folks, and I'm proud to be a part of it, even if only as a tiny atom inside modern gasoline. This is what's behind the gasoline you sell, whether from tank truck or on the service station driveway. Behind these symbols of service is a great record of scientific achievement that certifies today's leadership and guarantees tomorrow's.